Good evening, everyone. Thanks for spending your evening with us. So today we're going to be talking about securing EFS for containers and data science apps. We're super excited about this session. There's a lot of new material and content in here. I'm Willow Chandarina, product manager on the Amazon EFS team. With me today is Geert Jansen, another product manager with the EFS team, and John Fautley, chief cloud engineer at Cube Research and Technologies. So I'm going to start us off, and then each one of them will come up and present a piece of this. So what we're going to be doing today is starting off by just doing a quick introduction of EFS, just a couple of minutes to level set on what EFS is and how it relates to all of this. Then I'm going to walk us through some basics of securing EFS. So this is the kind of stuff that you need to know for any use case that you'd be running on EFS, how to secure it. And we're going to deep dive on how some of those things work. Then I'll pass it off to Geert to talk about special considerations for securing EFS specific to modern applications running in containers and environments with data science and data scientists. Then he's going to pass it off to John, who's going to walk us through a customer case study from Cube Research and Technology. Before I get to the material, just calling out a couple of other sessions. So tomorrow morning, there will be a general session on what's new in AWS file storage. Definitely recommend signing up and going to that one. It'll be across the portfolio, not just EFS, but FSX and other things as well. And then the third one down is a deep dive on EFS. So it'll go beyond just the security stuff and deep dive on performance and availability, durability, and all the different aspects of EFS. And then if you're into security, Geert has a chalk talk tomorrow on security best practices with Amazon EFS. I'd also recommend you guys checking out that one. It's going to go even deeper than this session today. So let's start with just a quick overview of Amazon EFS. So Amazon EFS is a fully managed cloud file system that's cloud native, highly reliable, and cost optimized. So when we say cloud native, what we mean is it's elastically scalable, as you would expect a native cloud service to be. And it's integrated with several other AWS services so that you can create modern applications using it. So some examples are ECS, Elastic Container Service, Elastic Kubernetes Service, SageMaker, just to name a few. It's highly reliable, so Amazon EFS is a regional service, which means all data is durably persisted across multiple availability zones. So Amazon EFS will be durable and available even if not all of those availability zones are. And it's cost optimized both because of the elasticity, so you pay nothing until you put data in, but also because of our EFS infrequent access tier, which uses lifecycle management to intelligently move data from EFS standard into EFS infrequent access at a 92% lower cost. EFS was designed for a wide variety of use cases, so everything from the use cases on the left, which are more single-threaded, single-host, metadata optimized, to everything on the right, which is more scale-out analytics. You notice that today's talk kind of tackles both of those, from the container storage on the left to the analytics on the right. So that's the quick overview of Amazon EFS. Now let's talk about some of the things that you should know just about how to secure EFS before we walk into how to do it for containers and data science. EFS has several security capabilities built in that we'll deep dive on, but the quick summary is you can control network access to Amazon EFS using VPCs, network ACL, security groups, things like that. We'll talk more about that. Using POSIX permissions to control file and directory access. You can control administrative access to the API using IAM. You can encrypt data both at rest and in transit. And all of these things together have helped EFS achieve compliance certifications for several of the compliance standards that you see here. So now deep diving on some of these. So first, controlling network access to EFS. So one of the main things you want to make sure that you're doing when you have EFS is ensuring that only the hosts that you trust are connecting to it. And the first line of defense for that is controlling network access to your file system. So the first thing to keep in mind is when you have an EFS file system, that EFS file system has mount targets. Those are what the NFS clients connect to. Those mount targets are in your VPC, which means you cannot connect to an Amazon EFS file system from outside of that VPC unless you've done something at the network layer to allow that, such as a transit gateway or a peering link or something similar to that. So the next line is, once you are in that VPC, you will only have access to a file system if the security group permits it. And there's generally two ways that people use in order to use security groups in order to control access to the file system. There's IP-based, which is you explicitly define in your security group statement which IP addresses are allowed to connect to your file system. So you see in this case, we've specified a single IP that we trust to connect to our EFS file system. Another way that you can do it is by using security group IDs to control who's allowed to get to your file system. So this might be a way of managing this at higher scale. But in this case, you see in the allow statement that anything from a particular security group is allowed to mount EFS, and then you just assign that security group to whichever host that you want to have access, and then they have access. You may use these in combination. So for the host that you own and you're deploying and you control the security group configuration for, it's easy to just tag your security group on there and have that go through the second way. If there's any host that a developer or somebody else has already deployed that you want to give access, then you might explicitly put the IP address in your security group statement. Next, when you're thinking about how to secure access to specific files or directories, like any local file system or network file system, EFS uses POSIX ownership and mode bits. So each file and directory is owned by a particular user, owned by a particular group, and has permission bits that say whether each of those, whether the user, the group, or everyone is allowed to read, write, or execute it. So you see kind of an example policy here of two BI users, Sally and Bob, each have different user IDs. They're in the same group. And then the way that's manifested on the file system is two home directories and then a shared directory that they can each access. Now the thing with users and groups is it's from the perspective of the client. So EFS, like any NFS server, will trust the client when users and groups are specified. So it's really important to make sure that you own your clients and you ensure that those clients are authenticating users and ensuring that the right users and groups are being sent over the wire. So this is why you might want to be restrictive with your security groups and make sure that you're managing those individual machines. In the cases where you can't do that, we'll talk about that in a little bit. Next, like I mentioned, EFS supports data encryption at rest and in transit. So when you enable your file system, it's super easy to turn on encryption at rest. All you have to do is link it to your key store, pick a master key, and then create your file system. Encryption in transit is something that we've also implemented. And the way that works is we use TLS tunneling between the client and the EFS mount target, and then we ride the NFS connection over that. And it's super easy to set up because we have the EFS Mount Helper that orchestrates all of the aspects of it. You can kind of see the relationship between each of these components here. So when you use the EFS Mount Helper and you do a mount EFS command on your Linux machine, what that Mount Helper is going to do is first set up an S-tunnel, which is an open source tunnel software that's going to establish the TLS tunnel from your client into your EFS mount target. And then it's going to set up an NFS connection to localhost, which will end up writing over that connection all the way into EFS. So this ensures that you can have fully encrypted data in transit without having to set up something complex like Kerberos. Next, like I mentioned before, you can control administrative access to the EFS API through IAM. The easiest way to do that is to attach to our managed policies. So we have two EFS managed policies. One is Elastic File System read-only access, which you can do to describe file systems, describe mount targets. This is a permission that you can give to your users just to make sure that they can discover their file systems and know how to connect to them. There's also full access, which allows you to create file systems, update them, delete them. These can all be tied to a specific resource. So if you want to give a particular user access to describe file systems for a particular file system or all file systems carrying a specific tag, you can do that as well. So those are the basics of securing any EFS. Now I'm going to invite Geert to come up and talk us through how you can think about securing for containers and data science apps.
Yep. Thanks, Will. Okay, so let's first talk a little bit about modern applications and sort of modern data science. And so the cloud has changed, quite a couple of things there. Customers, want to make use of the sort of the agility benefits, the elasticity, the cost benefits, and that sort of has changed how developers and data science people use, their resources. So, where you'd have a traditional application, where you might have been using shared application servers, maybe Java middleware servers. We have multiple applications running in the application server. Those servers would typically be deployed and managed by IT, so very standardized servers, probably, with configuration management, configured in a certain way. Now, if you then look at the modern applications, it's actually much more flexible. So, your developers, they're likely, provisioning their servers themselves, whether it's app servers or whether it's container-based applications. Same is sort of true for data science. Traditionally, data scientists were also using shared servers. That meant that you had to manage the IDs properly because you have multiple, developers on the same server. So likely you're going to need something like a directory, like LDAP or AD, to manage those IDs. Likely, the admins or the sort of owners of the platform have defined certain toolkits that you're allowed to use as a data scientist that would be installed by default on that server. But today, obviously, that's sort of not how people want to use or how data science people want to use their resources. They want to be much more dynamic. So they might spin up their own notebook servers with SageMaker or so. They might deploy their own skill-out training jobs for machine learning and so forth. So sort of summarizing, where traditional applications were sort of static, fully locked down, fully managed by the IT environment. People or users would not have root access on those servers, just normal users. In a modern application, you've got these sort of dynamic servers, these dynamic notebook servers, containers that are, likely managed by your developers or by your data scientists. They would still be sort of semi-trusted. And with semi-trusted, I mean that, these people still work for your organization, right? So it's not like there's some outside people, that are sort of not under your control on those servers. But the servers are being managed by these individuals. They have likely root access. So they're not sort of fully trusted as they were before when IT was managing everything. So if you then bring it back to sort of storage, how do you deal with that, right? So in the case of NFS, we've seen that the industry standard for managing access to NFS file shares is using IP addresses, subnets, but something tying back to network controls. But in these dynamic environments, you don't know really, where all your servers are going to be, right? They might be in the same VPC, they might be in different VPC because I don't know, the customers, that's where your developers want to spin up their resources. And so how do you manage that? Now, if I were a customer, and we try to obviously, understand what our customers want, what I would like is I would like to have some kind of sort of cloud-native, scalable, mechanism for managing access to my file system. So ideally, I would like to use IAM. I'd like to use entity-based policies. I would like to use resource-based policies. I would like to use these policy statements to say which clients can connect to my file system and with what permissions. What I also would like is maybe some kind of policy enforcement way of enforcing policies. Using IAM policies, for example, to enforce TLS, so that my end clients are connecting to my file system using a secure connection. And so we're happy to announce that actually we will be making a feature available very soon called IAM authorization for NFS clients that will allow you to use IAM to manage access to your NFS clients. Similarly, you might want to control, within the file system, what kind of directories are available to your data science users. And this can be done with some container-specific configurations, and we'll talk about that in a bit. Okay, so how does this work? So I think this is actually a really cool feature. At AWS, we're constantly innovating. We're constantly trying to make things easier for our customers, and this is a great example, right? So officially, NFS, predates IAM by quite a bit, right? So IAM itself is not a native supported authentication mechanism for NFS. So what we did is we basically are providing a way in order to use X509 certificates to use IAM to authenticate to EFS. So this will establish the client IAM role with cryptographic security to EFS, and then will allow you to use policies to control what are the things or what are the permissions that the client can use. In this example, you could, for example, have an identity-based policy that would be attached to the role of the end client. And in this case, it has a simple, elastic file system : client star action, which means that any client action is allowed for the specific workstation. So, you could use this, for example, for a management workstation that you want to give full access to your file system, including root access, and this would allow that. We also support resource-based policies. So resource-based policies are attached to the file system as opposed to the identity-based policies that are attached to the identity. So they look like this, very similar, but rather than specifying the resource, you would specify the principal. In this case, there's an AWS principal called my role that would be allowed full access to the file system. But what you would normally do maybe is scope this down so that you'd give by default maybe just read-only or read-write access, but reserve root access to the administrator. Okay, let's look at some more examples of how this would work. So in the first example, we have a principal star. So this would be an anonymous client that is connecting to the file system. And in this case, the client is able to mount the file system, which also implies read permissions, but is unable to write to the file system. So this is a way to give read-only access to a client that does not have an IAM role. This is useful for things like machine learning inference, for example, where you don't need to have write access to the model, you just need read access. And this is also very low implementation cost because your existing clients, even if they don't have an IAM role, can still use the file system like this. This is an example of giving write access to a principal. In this case, there's a role called semi-trust. And as you can see, it has two permissions, client mount and client write, which allows you to get read-write access to the file system. In this case, the root user is not able to write to the file system because we'll show it in the last example. There's a third permission that's called client root access. And if you want to write to the file system or read from the file system as root, that permission is required. Traditional NFS server implementations call this root squashing. And so this is sort of the inverse of that. So if you do not have the client root access permission, then you are basically root squashed. But then the cool thing about this is that you can use your IAM policies to manage that root squashing in a very scalable way. rather than things like exports list and so on. Finally, enforcing policies. So you might have a security policy that requires your clients to use TLS. Because this feature is based on IAM, you can use any of the default condition keys in your policies to add conditions to those actions. So in this case, we define the condition on AWS secure transport, which is only set if you use a TLS connection. So if you have this policy on your file system, your clients are required to use TLS. So this is a requirement that we often hear from financial services customers, for example, that have a internal compliance requirements that all connections are encrypted, and this would be one way to enforce that. And I'm going to hand it back to Will.
So here mentioned a minute ago in the first slide, so beyond controlling using IAM who's allowed to connect to your file system, when you're using EFS from other frameworks such as Kubernetes, such as SageMaker, oftentimes you're in situations where multiple users are sharing the same file system, and you want to make sure that you don't give a user access to a whole file system, that you give them access to their specific view of it. And that capability is built into some of these integrations that we've done. So in the case of Kubernetes and Elastic Kubernetes Service, this is handled through the separation of duties that is built into Kubernetes with persistent volumes. So this kind of gets into all the mechanics of persistent volumes, but the important thing here is with Kubernetes persistent volumes, the administrator upfront creates the file systems, creates paths within those file systems, and creates something called a persistent volume, which is an available storage resource that can be allocated to a developer when they launch an application. And what Kubernetes does is when a user comes and they launch an application and claim one of those persistent volumes, Kubernetes ensures that that volume is locked to that user and that data cannot be read by anyone else. And likewise, when that specific path in a file system is mounted into the container, it's mounted at that path, so the container can't do a cd ... out of it and see any other user's data. So that's an example of how it's handled at the Kubernetes layer. Likewise, earlier this year, we integrated with Amazon SageMaker for model training use cases. So with this integration, users can launch training jobs with SageMaker that point at a file system and a specific path in that file system to train a model. And along with this integration, what we wanted to do is handle the case where multiple data scientists are sharing a file system. Oftentimes in that case, each data scientist has their own home directory. And we wanted to enable the case where each data scientist is allowed to launch a training job in their own home directory or maybe in a shared directory, but potentially not in whatever directory contains PII information or something that would be more sensitive. So we've made it really easy to configure that also using IAM roles, where you can see that there's this action create training job. It's the same action, but there's condition keys for all of the file system configuration that you'd put in. So it can control which file system a user is allowed to train on, whether it's read-only or read-write, which path they're allowed to mount to. So that way you can ensure that you're giving the proper privileges to each of your users that are launching those training jobs. So you can even you can put these things together for building out these data science environments. So think of a case where you're running, each user has their own notebook server. So in that case, you could use the IAM roles. So you could give the notebook server the IAM role that gives them specific access to the file system. And that notebook server would be kicking off SageMaker training jobs, which would be governed by the SageMaker identity policy that we just mentioned. So you can kind of control it from both sides, both the notebooks and the training jobs. So with that, I'm going to hand it over to John, who's going to tell us about what his environment looks like and how you might use these.
Thanks, Will. Good evening. My name is John Fortley. I'm here from Cube Research and Technologies, and I'm going to explain a little bit about how our data science architecture and environment's put together. But first things first, explain who we are. We're a quantitative and systematic investment manager. We've got a fairly long pedigree in the industry. Previously, we were part of the global investment bank Credit Suisse, who I'm guessing most people in here have heard of. And about 2 years ago, we went through a privatization move, so we're now a separate privately owned company. And as part of that, I was brought on board to help with our research and our data science environments and bringing that from a legacy AWS environment in Credit Suisse into our own new greenfield site deployment. So as a firm, we are technology driven. We obviously focus heavily on research, and the clue is kind of in the name. And we've got a global market presence, so we operate across all of the major financial trading exchanges worldwide. And in terms of physical presence, we've got offices in London, Hong Kong, Paris, and Mumbai. So I'll explain a little bit, sort of a high-level view of our data science architecture and the different components that make up that stack. One of the things that I did when I was brought on as part of the separation was to make sure that we treated AWS as an extension of our internal network. We didn't want it to be this big, scary, ooh, cloud, can't possibly put anything in there. We wanted to treat it just as another data center. And that's really helped us with our consumption of Amazon and AWS services. So we've got our corporate offices, we've got our researchers, our quants, and also our traditional server estate running various applications, legacy applications, as well as modern data or modern cloud native apps. We have direct connect into AWS, where we have our data science platforms. And I'll start, like all good stories, in the middle with Amazon Workspaces. So we use Amazon Workspaces to provide Windows desktops for some of our users and them to run their applications on. And that talks to FSx for Windows for storage. We also use Jupyter notebooks. So I mentioned earlier on SageMaker notebooks. So Jupyter is the open source project that allows you to provision, originally started out as Python, but there's now multiple languages and frameworks and things as well that allow our researchers and data scientists to manipulate and calculate on the data that they need to. And we also have a bespoke high-performance computing grid, which allows us to do massively parallel computations and compute jobs. So a good example of that is financial backtesting, where we replay market data and then run that through our new algorithm or new software and see how it performs. As I mentioned, data is also really at the heart of what we have and what we do, and we pull in a lot of data from external third parties as well, and that tends to come over the public internet, and we store that in S3. So we have external third-party data plus data mastered internally, which goes into S3. I want to dive a little bit into the way that we use Jupyter, because that's my favorite part of the whole stack. And as I mentioned, we use something called Jupyter Hub, which is a way of orchestrating and managing the life cycle around individual notebook instances. So a user will open up a web browser. They'll authenticate using their standard Windows domain credentials. And as part of that, we go off to AWS Directory Service and we look up not just their, are they the right user? Have they given them the right password? But also their POSIX permissions, their user and their group ID. And more importantly for us, what particular team they sit with and what they should and shouldn't be able to access in terms of data sources. Once the user's logged in, they can then specify the type of instance that they want. And that can be anything from a small, couple of virtual CPUs with 4 or 8 gig of RAM, all the way up to a completely dedicated underlying EC2 instance, depending on the nature of the work they're doing and the job that they want to run. And once they've selected that, the hub will go off and it will look at the correct namespace to start that in for the relevant user, and it will then spin up a per user container consisting of the Jupyter Notebook instance itself. It will also attach an IAM role, and then we'll then use the standard Kubernetes persistent volume claims to also mount the EFS file systems that are needed for that particular user's work, whether that's their home directories or a desk-specific sort of catch-all or shared file system for them. And again, we currently use the IAM roles to authenticate access to S3. So we have desk-specific S3 buckets. We have certain types of data that is restricted, whether it's by licensing or who can use it or region. And we access via an S3 endpoint to talk to the S3, the relevant S3 buckets, again authenticated via the IAM role assigned to the notebook itself. So why do we use Amazon EFS? It started out because we still have a number of legacy applications. We were part of Credit Suisse for nearly 15 years. There's going to be a lot of applications that are still extremely functional, but maybe haven't been reworked or rewritten to work in a cloud-native way. So we found that having the ability to use a standard POSIX file system was great because our applications continued to run exactly as they did before, and we didn't have to worry about rewriting them. And as Will has mentioned, EFS brings cloud-native performance, and more importantly, from my perspective, convenience as well, because I don't need to think, or users don't need to think, oh, we need to pre-provision, oh, I need 2 terabytes of storage. Oh, no, actually, it needs to be 4 terabytes. Sorry about me. It just automatically and elastically scales, depending on our users' needs. And the other thing is it's the risk of a bad user impacting the storage for everybody else is significantly reduced. Those of you that have worked in large enterprises will know that enterprise storage is not a free-flowing commodity, so you need to be aware of what you want to use it for, what class of storage that's going to be. And unfortunately, that's come back and that has bitten us a few times, whether that's this standard case of a user filling up the file system and nobody else can write any files, or more critically in our case, it was somebody trying to run a compute job and then just monopolizing all of the IOPS on the underlying storage as well. So again, that means that the file system, one, it's got plenty of space, it's quite happily ticking along, it's unusable for other users as well. Again, all problems that we don't have with EFS, thankfully. And the other thing is it makes our cross-team and cross-region collaboration significantly easier. So I'll give you an example of the way that we do some cross-region collaboration. So we have a bunch of on-premise storage, and we're quite heavy users of AWS's data sync service. And that allows us to synchronize data both into EFS and also into S3 from on-premise. And what we're also looking at doing is using data sync to synchronize between EFS and S3, and then using S3's native cross-region replication functionality so that we can move data from one region to another without having to sit there and tediously copy files and so on and so forth. So you've heard about the IAM authorization for NFS clients. The big problem that we had previously was that we had to, as has been mentioned, we had to have our core IT teams building the instances, building the containers, making sure that a user couldn't elevate their privileges to root, couldn't do something that maybe they shouldn't be doing. And that meant that any new update, any new change had to be vetted by our core IT teams, both from a security point of view and just simply a functionality point of view as well. Our core IT team are not experts in all areas. I wish I was, but unfortunately, the latest programming language that somebody wants to use, or there's a new version of a particular framework, whether it's TensorFlow or MXNet. Yes, it's great. I can Google, but I'm not the expert in that. That's why we have our wealth of data scientists and researchers. And of course, those of us that work in IT and work in system administration know that we are fundamentally quite quite busy with other tasks. So we don't want to spend our time rebuilding and testing and maintaining what people are doing. We'd rather just give them the ability to do that themselves. So the IAM authorization for the NFS clients means that we're able to extend that scope of trust. I can give our internal data science teams, our researchers, the ability to build their own Docker containers or build their own instance types or whatever it might be. And that then means that because I can restrict what they're doing based on the IAM role that's assigned to them, they can't say, oh, well, actually, I'm root, so I'll just, I'll quite happily go off and, access everybody else's data and so on and so forth. So I'm really excited about this feature. I'm really pleased that it's something that's going to be coming up soon. So, thank you. I'll let Will and Geert come back up and I think I should need that.
Thank you, John. So we can transition now to Q&A. Love to get your questions and talk about whatever is interesting. We've got a mic up here if you want to come up to it, or you can just yell it out and I'll repeat the question if you're busy. Yeah.
Security group, port 2049. The documentation online doesn't say that inbound, outbound, or both.
Question is, do you need to enable port 2049 inbound, outbound, or both? Both, I believe, right?
Yep.
Yep.
And hi.
Hi.
I was last night on a session with the Lex team, and they mentioned that they don't use SageMaker because they found some issues when trying to use also EFS. They run into some limitations. Then I asked the SageMaker guys what happened there, and they told me, oh, that must be EFS limitations. Something about IOPS, like maybe the Lex team actually hit limitations on EFS directly. Do you know anything about that?
I'm not aware of that specific issue. I'd love to find out more about it.
Do you know what are kind of like the natural limitations of EFS?
Sure. So when you set up an EFS file system, you can configure one of two performance modes. One is called general purpose. The other mode is called max I/O. General purpose mode file systems are optimized for low metadata latency. Those file systems have a IOPS limit of 7,000 today. Max I/O file systems are optimized for massive parallel I/O and have no IOPS limit. We have customers running them up to 500,000 IOPS. So generally what we would recommend for SageMaker users, since it's more of the parallel I/O case, is to create a file system with max I/O mode. Without knowing more, and we should talk more about it, I would guess that a max I/O file system wouldn't have had that issue.
Question over there.
I got our studio running on a Kubernetes cluster in EKS right now. If I were to get the authentication for that application going through Cognito with delivered IAM in some way, could I get the users logging in using Cognito back to Active Directory and use those properties to control their access to the file system that I have mounted to those containers running in EKS? I'll use that as well.
Do you want to try that one?
So I think the question is, use Cognito for user authentication. That vends IAM credentials, and do they somehow have like an ID embedded into the credential?
And so if they're logging into the application using Cognito, using their Active Directory credentials,
Right.
could I pass that through and then leverage the IAM authentication to the EFS file systems backing those containers?
So the way this works is that our IAM integration authenticates the client. So if NFS clients or instances or containers each of them have their unique identity, then yes, that identity is authenticated to EFS. That would be the identity that you would use for granting access.
So if I say gave each user then their own container that only they had access to, then they could use that to securely access the file system. But if I had several users sharing a single container, then it would have to be the identity of the container.
That is correct. Yeah, this focuses very much on sort of the case where you have applications running, in containers or on servers, but where that container is running one application, and therefore you authenticate the container to EFS. Yeah.
So the permissions are evaluated at mount point, or at the mount time?
Yeah, that is correct. So if you see like there's three permissions, there's read only, read write, and root access, and those are specific to the mount itself. They're not specific to the user on the mount. So it's still a multi-user mount. The EFS will still trust the POSIX IDs that are used on top of the mount. But what you have is there's some restriction at the mount level, so that, for example, you can't use root, or you can't write to the file system. Yeah, so it's very similar to sort of how the export lists work, in sort of enterprise NAS or Linux NFS server.
Two questions. How or immediate style affects performance? So all this encryption you're using
So let me repeat the question. The question is, how does IAM impact performance?
S-tunnel.
S-tunnel, okay. We've done a lot of optimizations to it, so there's no, obviously there's some CPU that you'll use, but the modern processors all have like dedicated instructions to do the encryption. So therefore, there's no noticeable performance impact when you use TLS versus non-TLS. Yeah.
Have you tested or just an assumption?
No, we definitely tested that. Yeah. Yeah.
Again, on the permission questions, when we mount the file system, it is like if it goes with the user ID and the group permissions, all the group users having the root access. Is it possible, or do you have an isolation on IAM user-based access?
So is the question whether there's a way to restrict the POSIX IDs on a given connection? Is that the question?
Yeah.
Yeah. So today, no. So today, what you can do is you can limit the root user, which is the equivalent of root squashing on traditional NFS servers. But outside of that, we still trust the IDs that are being presented by the client.
Sure. So our use case is like we have 100 users sharing the same file system, but we don't want to have the other user directories to be visible to the same group. Even if it's the same group, like we want to isolate. In today's one, whenever like we mount, it goes with the same IAM user and the group permissions. So we're not able to isolate that one.
Yes, so this feature is very much designed for authenticating the endpoints, which is step number one in sort of what you're suggesting is end-user authentication. It is a common request we're getting from customers, and obviously as a customer-driven company, we're always looking at some of those, at implementing some of those improvements to the to the solution that we have right now.
Cool. And the second one on the slide I see, the SageMaker is getting mounted on EFS with a single file system where they have the home directory visible to all and the training or the models can be restricted to the user-based. Is that what the IAM policy is doing?
Yes, so with the SageMaker IAM policy, which you can, so it's an identity policy, so it would be attached to the user or IAM role and say, so today you can give access to train models or not train models just overall. And with these new condition keys, you can say this user can train a model using this file system or this list of file systems and this path so it's file system, path within the file system, and whether it's read-only or read-write.
Okay, so you're saying like we can restrict a path within the file system.
That's right.
With the users.
That's right.
The last question is like we are trying to back up EFS, a single directory, like in EFS, and under EFS, like if you have like 10 directories, we want to back up a single one to Amazon backup. Do you have a provision for this?
Not today, but like Kiert said, that's good feedback. We'll take it into account. We're always looking at ways to.
Like it's a big one, like 100+ terabyte file system. We cannot do the entire thing to a backup. We want to like isolate to one particular folder where we need a backup.
Okay. Thank you for the feedback. Any other questions? Okay. Well, thanks again for spending your evening with us. We'll be up front for the next couple of minutes in case you have something you did want to say in front of everybody. So thanks again.
Thank you.